Hello, everybody. So this is going to be chapter 7, and to be honest with you, this chapter is really small, so these videos are not going to be big, okay? And this chapter 7 and chapter 8 form the foundation for MAT080, MAT108, which is intermediate algebra, trigonometry, pre-calculus, analytical methods, calculus, you name it. These next two chapters are going to be massively important for that strong foundation. So chapters 1 through 6, what we learned were just all the different types of numbers that we have and how do we actually use the operations with those numbers. Chapters 7 and 8, we start to form those algebraic abstract ideas that takes those numbers and then puts them into problem solving and critical thinking applications. So the first thing we're going to be talking about here are just rational and irrational numbers, okay? And once we determine the differences between here, we're going to go over this new type of number. Well, it's not a new number. That's bad for me to say. We're going to basically summarize everything that we know about numbers into what we call the real number. So first, let's talk about a rational number. So a rational number, and you already know what this is. This is just a formal definition now. A rational number is a number that can be written in the form P over Q, comma, where P and Q are integers and Q is not allowed to equal 0. So before I even move on after this, okay, I just want us to kind of look at what we've studied so far. So let me go ahead and share my screen real quick because I have our book open. So if you look over here on the left-hand side of our screen, okay, and I'm just going to go ahead and click on these. Notice chapter 1, we talked about whole numbers. Chapter 2 was the language of algebra. We started learning about terms and everything. Chapter 3 was integers. Chapter 4 was fractions. Chapter 5 was decimals. Chapter 6 is percents. Today, we're going over the properties of real numbers. So if you think about it, a rational number, which literally this is the definition that we just wrote on the board. This is our definition right here. A rational number is nothing more than just a fraction. And we know fractions are nothing more than just integers that we found in chapter 3 written as a numerator and a denominator. And we know integers are also whole numbers in the sense that integers are positive and negative whole numbers. So all this just kind of flows together. So when we talk about a rational number, what we're talking about is nothing more than just a fraction. So rational numbers. Man, my handwriting is terrible today. Let's clean this up. Rational numbers, to be honest with you, are just fractions with integers as the numerator and denominator, okay? More importantly, whole numbers are also rational numbers, okay? Because what we could say is if we have the whole number 3, we could easily make that a fraction just by putting it over 1. Hence, you have a fraction with integers. They just happen to be real numbers, but more importantly, it's a rational number, okay? So the key to understanding what a rational number is nothing more than, can you write it as a fraction? If the answer is yes, then you have what we call a rational number. And even look at the root word in the word rational, ratio. And we just learned what ratios were. They were fractions, okay? So, excuse me. So I'm going to do a couple examples here of just being able to identify rational numbers. And we're going to come back to this fundamental question. Can you write it as a fraction? So here's the first one. -5. Well, I can always rewrite -5 as -5/1, hence rational. Okay? Also, here's another one. How about 3.2? Well, if you think about 3.2, we know we can convert a decimal to a fraction by writing 3 2/10. Okay? And then we could take that one step further. We could say, well, we can reduce it to be 3 1/5. And then we could take it one step further and convert it into an improper fraction. So 5 times 3 is going to be 15, plus 1 more is 16. So 16/5. So yes, 3.2 is a rational number, okay? It may be written as a decimal, but once we go through our technique of converting a decimal into a fraction, we have what we call a rational number, okay? Even decimals that repeat, such as 0.333 repeating. Like we know 0.333 repeating is 1/3 as a fraction. So this is a rational number. Okay? However, sometimes you run into this situation here. Now notice I'm going to draw this big line right here because this is going to divide us. Sometimes we run into what we call irrational numbers. Okay? And to basically summarize what an irrational number is, it is a number that cannot be written as a fraction. Or in parentheses, I'll put a rational number. Now, you already know a couple of these, all right? And the most famous irrational number that we're going to look at is pi. Pi is an irrational number. Now, what makes it irrational is the fact that when we write out pi, and these are just the first, 9 or 10 digits, okay, of pi, notice this decimal part is non-repeating. And because that decimal part is non-repeating, that is what makes this a rational number. Or, I'm sorry, irrational number, okay? Let me write that down because I misspoke. This is an irrational number. Okay? Another irrational number, another famous one, is the square root of 2. So if we pull out our calculator here, let me change this from standard into, no, standard will work. So if I hit the square root of 2, notice I get this crazy number right here, whatever that is, 1.412, blah, 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 blah. I'll copy and paste it right here if it'll let me. Bingo. Maybe I'll paste it as a picture so I can move it around. Oh, well, it's not going to let me. I don't care. I'm just going to put an equal sign here. And make it a little larger. There we go. So the square root of 2 is this crazy number right here. And to be honest with you, it keeps going. It doesn't repeat. It's just my calculator can only show so many decimal places. Okay? So just to summarize what irrational numbers are, all right? An irrational number, decimal, does not stop nor repeats. Okay? So what I want to do here is just kind of go over three easy examples. And we just want to identify, are they rational or irrational? Okay? So the 3 examples I have are going to be 0.313. Actually, let's make it 314. 0.583 repeating. And then 3.6218425978, and just keeps going with random digits. So I'll just put random digits here. All right, while the first one, it stops. So we know this is going to be a rational number because it stops. The second repeats the same digit, which is 333333333, and that's okay. We call that a rational number. All right, the 3.618425978 with a bunch of random digits after that is definitely going to be irrational. Just like an irrational person doesn't make sense, an irrational number just keeps repeating and it doesn't make any sense. Now, there are some numbers that we explored that we need to be a little careful of, okay? So the first one is going to be like the square root of 36. So we know the square root of 36, okay, is going to be 6. Now, we studied square roots a while ago, okay? So just remember that the square root of 36 is 6. But notice this is a rational number. And that's because we get this nice whole number, which we know we can write it as 6 over 1, so it's rational. However, the square root of the square root of 17 is just, it's an irrational number. Now, there's a really easy way. There's a really easy way to go ahead and determine, well, how did we know that the square root of 17 is irrational? All right, and it goes back to when we studied square roots. So if you want to give me 1 second here, I'm going to find those notes for us. All right, so I'm back, and here are the notes that we kind of looked at square roots. So if you go back to Chapter 5, Section 7. Now, there is a video for that back in Chapter 5, Section 7, so make sure you check that out. But here's how we can easily tell the difference between an irrational number and a rational number when we're talking about square roots. It all comes back to this table right here. If we look at this table, all of these numbers in the bottom row, let me highlight what I'm talking about here. All of these numbers in this bottom row are all perfect squares. So we know the square root of 1 is 1, and the square root of 4 is 2, and the square root of 9 is 3, and the square root of 100 is 10, and the square root of 49 is 7, and so forth. If our number that we're looking at is not one of these special ones, it's going to be irrational no matter which way you look at it. So if you think about it, we had the square root of 17 for a question. Well, that is going to be in between the square root of 16 and the square root of 25. But more importantly, it's an irrational number. Okay? So that is that's a quick, easy way of determining whether or not a number is rational or irrational when we are talking about square roots. Okay? Now, your book does a really, really good job at kind of showing you here the difference between an irrational number and rational numbers and everything. So what I'm going to do is I'm going to show you this photo real quick. So here's our book, and if you notice here, all right, this inner circle or this inner square, so hopefully you could see my mouse. I know it's kind of hard to see it, that's why I'm trying to move it, but I'm going over the word counting numbers. That was the first thing that we learned, okay? At the very start of the semester. So we had counting numbers, and counting numbers started at the number 1 and then got positive, 1, 2, 3, 4, and so forth. Then we learned about whole numbers. So if you look at this red square, all right, or this red rectangle, notice that it's sitting on top of the whole numbers, and that's because all counting numbers are also whole numbers, okay? The only difference between a counting number and a whole number is the number 0. So 0 is included in the whole numbers, and then it also includes all the counting numbers as well. Then if you kind of expand your focus a little bit more, you have this this like darker blue, we'll say darker blue square, that is a rectangle, that are the integers. So counting numbers are whole numbers, and whole numbers are integers, which means counting numbers are also integers as well. So like I said, if you think about just sitting on top of each other, all right, that's what's happening. And then we have rational numbers, which we know are fractions, where they have positive and negative integers for the numerator and denominator respectively. And then we just introduced this entire new branch of math, okay, which are numbers, which are irrational numbers. And sorry, my Steam notifications are going off, so I'm going to go ahead and just close Steam for us real quick. There we go. So in this light blue, or if you want to call it like teal. No, I don't think it's teal. Maybe teal on your screen. For my screen, it's light blue. They're called irrational numbers. And notice how they're separated. So rational numbers and irrational numbers are not the same thing. They are different. That's why they're separated. However, if you bring all of these numbers together, now we're on this green rectangle in the background, and we call them real numbers. And real numbers are all the numbers that we know about, okay? So let me go ahead and let me write that definition down. Okay, so real numbers, I'm going to write it in black because this is really important here. So real numbers, and this is what we're going to be focused on from now until you are done with mathematics. Real numbers are numbers that are either rational or irrational. Okay, now an easier way to kind of describe the sentence, and I'm going to put a star next to this, is any number on a number line is a real number. So if I can draw a number line and put a 0, 1, 2, 3, -1, -2, -3. In fact, you know what? Let me do it like this. I'll build it for us. You ready? Watch this. Here's our number line, okay? Now, I want you to get that picture. Actually, you know what? I'm going to pause the video. I'm going to copy and paste that picture directly underneath here. I'm going to show you how I'm going to build this. Watch. All right. Here I am. I'm back. And watch this. So, counting numbers are 1, 2, 3, 4, 5, 6, 7, and so forth, okay? Now, if we expand a little bit further out, whole numbers, I include 0. There are my whole numbers. 0, 1, 2, 3, 4, 5, 6, and so forth. Integers include -1, -2, -3, all the negative numbers, 0, and 1, 2, 3, 4, 5, 6, and everything else, okay? Now, let me get a different color here. Let me see. I'm going to use green for this one. So, rational numbers are all the numbers that you see here, and they're also things like 5/2, or 1/2, or -3/2, okay? Or, point right there, 1/3, which we know is a decimal. It's 0.3333 repeating, right? And now we have a new number, or new types of numbers, like this one right here, which is pi. And we know pi is equal to 3.14 and a bunch of other numbers, okay? We also know the square root of 17. Oh, sorry. The square root of 17 is somewhere in between 4 and 5. So right here is the square root of 17, okay? However, if you were to highlight all of these numbers here, and I'm going to highlight in yellow, okay? If you were to highlight all these numbers that we have here, we call them real numbers. It's everything that we know, okay? So hopefully that kind of demonstrates all of the different types of numbers that we have, all right? So inside your homework, you're going to have a couple questions that are going to ask you to determine whether the numbers in the list are whole numbers, integers, rational numbers, irrational numbers, real numbers, and you're going to click on the little check marks. I would use this table right here, this picture. Have this in front of you. That way, when you go ahead and you click on them, you can easily identify them. Okay? Here's an example right here. I'll do one example. So determine if each number is a whole number, integer, a rational number, irrational number, and real number. All right, and here are the numbers right here. -3, negative square root of 2, 0, 0.3 repeating, 9/5, 4, and the square root of 49. Okay, so I'm going to zoom out here. I'm going to write -3. And here's what we know. We know -3 is going to be an integer. Okay? Since -3 is an integer, or better yet, let's start at we'll start at the biggest number set. I think that's the best. -3 is definitely a real number. Which means it's also a rational number. It's also an integer. It's also a whole number. Oh, wait. It's not a whole number. I'm sorry. I'm moving too fast. So -3 is a real number, which means it's a rational number, which means it's an integer. And remember, integers are positive and negative whole numbers. Whole numbers are only positive. So there's -3 right there. It's all those different types of numbers. Next one is going to be the square root of -2. Well, the square root of -2, all right, is an irrational number. And it's an irrational because it never repeats, and it's not one of those special ones. 0 is a real number. It's rational. Because remember, you can write 0/1. It's an integer. And it's a whole number. It's not a counting number because counting numbers start at 1. Okay? 0.3 repeating. Remember, that's 1/3. Okay? So that is going to be a real number. Which is a, oops, sorry. Didn't even see that there. It's a rational. And that's it. It's not an integer, because remember, integers are positive and negative whole numbers. 4 is going to be all of them. So 4 goes from a real number all the way down to a counting number. So you would check on all of them for that. And then the square root of 49. Well, the square root of 49 equals 7. So that's going to be a real number all the way down to a counting number. All right, and that's going to be it for this video. So the next video is going to deal with commutative and associative properties. And it just basically tells us, okay, now that we have numbers, what are we allowed to do with them? And it's really simple. Like I said, I would imagine the next 3 lecture videos are going to be like 10 minutes max. They're very small, and they're very easy. So good luck. This is going to be an easy chapter. I'll talk to you in the next video. Bye.